Welcome back, everybody. This is Mr. Reeves with you again, and we are continuing to work through the Grade 8 CAASPP Math Practice Test. And we have now worked our way to question number 17. So we're going to be doing 17, 18, 19, 20, 21, and 22 in this video. All right, so let's get started with number 17. Marco says that the interior angles of a triangle add up to 180. He claims that the interior angles of a hexagon must add up to 360 degrees because a hexagon has twice as many vertices as a triangle and can be divided into two triangles. Therefore, its interior angles must sum to twice the value of a triangle. All right, so let's take a look at this problem. Why don't we start by making a triangle? So I'm going to make a triangle here, and I'm going to label these angles, angle 1, angle 2, and angle 3. All right, and it is a well-known theorem that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And if you'd like to see a proof of this theorem, there's a lot of different theorems out there. Maybe some of you have done that one where you tear off the corners and you put them all together and you get a straight line that adds up to 180. But it is true that the angles of a triangle add up to 180. All right, so if I were to attach another triangle onto this triangle, if I were simply to connect a triangle here on this side, right? And I were to call these angles 4, 5, and 6, and I were to ask you what do the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 add up to, well, they're going to add up to the same sum, which is 180 degrees. And I said, what about if I put those two together? What if I asked you what do 1 plus 3 plus 2 plus 5 plus 6 plus 4 add up to? And do you see how those all added up together give me the angles of this four-sided polygon? So those all added up together would be 360 degrees, right? I could put 1 and 4 together, and that's this angle right here. 2 and 5 together, that's that angle right there. And here's angle 3, and here's angle 6. But how many sides does this figure have? 1, 2, 3, 4. When you put two triangles together, you get a four-sided figure. So that means a four-sided polygon, or what we call a quadrilateral, the sum of the interior angles of a quadrilateral equal 360 degrees. So what about a hexagon? I believe I can make a hexagon here. No, that's not a hexagon, is it? 1, 2, 3, 4, 5. Let's ditch the pentagon and let's get an actual hexagon. Here we go. 1, 2, 3, 4, 5, 6. All right, and let's divide this up into triangles. So here we go. I'm going to connect this vertex to that vertex, and that makes one triangle. Then I'm going to go from this vertex, I'm off by a little bit here, to that vertex. That makes a second triangle. I wonder if I can fix this at all. There's no fixing it, is there? Oh, it's a little better, I guess. I don't know. Probably not worth it. All right, and then I'll go from here. Oh, that is way off. Go from here to here. All right, so it's not perfect, but you can see that I took this six-sided hexagon, and when I divided it up into triangles, I got 1, 2, 3, 4 triangles, not 2 triangles. 2 triangles gave me, again, this is called a quadrilateral. Quad meaning 4, and this is a hexagon, meaning it has 6 sides. A quadrilateral was 180 degrees times 2, giving us a total of 360 degrees. A hexagon is going to be 180 degrees, not times 2, but times 4, which is actually going to give us 540 degrees. So if we take a look at Mark's statement, which explains his error? Is it a hexagon does not have 6 vertices? No, a hexagon has 6 vertices. So that is not the answer we are looking for. Is it that a hexagon can be divided into 4 triangles? Not 2. Well, that sure appears to be correct. Let's take a look at these last 2 choices just to make sure. The interior angles of a triangle do not add up to 180. Actually, they do, so it's not that. And Marco's statement is correct and contains no error. No, we know it contains an error. So the answer we're looking for is B. All right, so I'm going to go ahead and mark B and move on to the next question. Number 18. Simone and Nang read a total of 23 books over the summer. Simone read 5 more books than Nang. Enter the number of books that Nang read. All right, so I'm going to go ahead and make a diagram for this one. So let's go ahead and get ourselves a rectangle, shall we? So I'm going to make a rectangle. And I'm going to divide this rectangle into 2 parts. Now we have Simone and we have Nang. Now, Simone read 5 more books than Nang, so I'm going to make Simone's part bigger. I don't know exactly how much bigger it is or how many more books it is, but I'm going to put Simone here, and I'm going to put Nang here. All right, and what do we know about this total? If this represents the number of books that they read, not rang, the number of books they read, it is 23 total books, right? All right, do we know how many Simone read? No. Do we know how many Nang read? No, but we do know that Simone read 5 more than Nang. So I'm going to call the number of books that Nang read N. All right, so we're going to say Nang read N books. All right, so Nang read N books. So then how many books did Simone read if she read 5 more? Well, how many did Nang read? N. She read 5 more. What do you do to get 5 more? Add, subtract, multiply, or divide? You add. So I'm going to put N plus 5. So this represents the total number of books that was read. Simone read N plus 5. Nang read N, and combined, and what operation do we use to combine? Those two added together have to equal 23. So I get N plus 5 equals 23. Well, I can put an N plus an N, and N plus N is 2 N's. Plus 5 equals 23, and I have a 2-step equation. The point of an equation is to try to find the value of the variable that makes the equation true. And we do that by isolating the variable, getting it by itself. And we do that using inverse operation. So I'm going to take away those 5 extra books that Simone read. 23 minus the 5 extra books leaves us with 18. So that says if they had read the same number of books, it would be 18, right? Because I took the 5 extra away. Dividing by 2, what do we get for N? We get N is equal to 9. So what does that tell us? That tells us that Nang read 9 books and Simone read 9 plus 5 books. and 9 plus 5 is 14. All right, and 14 plus 9, if we want to check our work, 14 plus 9 is 23. All right, it says enter the number of books that Nang read. So be careful when you're doing these problems. You can do all the work right and put the wrong answer in. So it didn't ask for Simone, it asked for Nang. Nang read 9 books. So we're going to say 9 and go on to question number 19. Oh, this one looks fun. All right, given triangle ABC, there's triangle ABC. We now know those angles add up to 180, huh? And there's triangle A prime, B prime, C prime, and those angles also add up to 180. Let's see what they're actually asking. Select true or false for each statement about the sequence of transformations that can verify that triangle ABC is congruent to triangle A prime, B prime, C prime. All right, well, I believe if you watched the previous video, we did a problem and talked about transformations. We talked about what it means for triangles to be congruent. Do you remember? Two shapes are congruent if everything about them is the same. So this triangle and this triangle are the exact same triangle, meaning if I measured these angles, angle A is going to be the same angle as A prime, angle B is going to be the same angle as B prime, and angle C is going to have the same measure as C prime. And from A to B is the same length as A prime to B prime, and all the other sides as well. They are congruent, and anytime you do those congruence transformations, and just a reminder what the three are, the first one is a translation. And remember, a translation is like a slide. We're moving it around. Then we had a reflection. A reflection is like a flip. And then finally we had a rotation, and a rotation is like a turn. All right? So, getting back to the question, it says, make it true. Determine whether each statement is true or false about the sequence of transformations. And by the way, a sequence of transformations is when you put several transformations together. So if you just do one transformation, we say it's a transformation. If you do more than one, we say it's a sequence of transformations. All right, so it's kind of hard because we have, let's see, can I make this a little bit smaller so we can see everything, the questions and the triangles? There we go, that's a little better. All right, here we go. Triangle ABC is reflected across the y-axis, followed by a reflection across the x-axis. Triangle ABC, if it were reflected over the y-axis, what would happen? Well, if I reflect it over the y-axis, here's my y-axis right here. There's my y-axis right there. So a reflection across the y-axis is going to move it over here. And what I'm going to get is the triangle, this triangle, and it's going to be on this side over here. So A is at -5, 7. A prime is going to be at +5, 7. So right there would be A prime. All right, and again, I mentioned this in the last one. These really should be double primes because it's the result of another one. Okay, so I'm going to call this one prime. C is back 3 and up 3. So C prime is going to be over 3 and up 3. So that one right there I'm going to call C prime. And B is back 7 and up 3. So if I go over 7 and up 3, that's where B prime would be. And if I connect those, let's get rid of that arrow there. If I connect those, then triangle A prime, B prime, C prime is congruent to ABC, and it is a reflection over the y-axis. Now, it says then it's followed by a reflection over the x-axis. That would be going down this way. Well, is that the case? Well, let's see. B prime is over 7 and up 3. B double prime is over 7 and down 3. A is over 5 and up 7. A prime is over 5 and up 7. A double prime matches up. So this is actually a true statement. All right, triangle ABC is reflected across the x-axis, followed by a reflection over the y-axis. Could we have gotten the same result if instead of reflecting over and down, we reflected down and then we reflected over? What do you think? Can you picture it in your mind? Can you picture flipping this down here and then flipping it over? All right, let's just look at one point just to see. Let's look at C. If I reflected C over the x-axis, this is the x-axis right here. All right, so it's back 3 and up 3. It would be back 3 and then down 3, right? So that would be my new C prime. And then if I reflected over the y-axis, do you see that's where I'd end up, right? So the answer for this one is also true. Now, it's not always true that transformations can be done in a different order with the same result, but with reflections over the x and the y-axis like this, it does work, all right? So that commutative property you guys know about, that applies in this case. Triangle ABC is reflected across the y-axis, followed by a translation of 6 units down. All right, so if we look at this last one, reflecting over the y-axis, that's what put us right here, right? Now, earlier I said that a translation, do you remember what we said it was? A translation is a slide, okay? It's like you put your finger on there and you slide it. You're not turning, that would be a rotation. You're not flipping, that would be a reflection. You're simply sliding it around. Now I want you to picture what would happen if I were to slide this triangle down. I'm going to go ahead and use orange because that's what I was writing in. If I was to slide this triangle down 6 units. So if I slid B down, well, there's 3 and there's 3 more. And you go, hey, yeah, it's in the right spot, right? Well, B appears to be in the right spot. Guess what? If I did the same thing with C, yeah, it's in the right spot. But what happens when I move, here, let me get rid of this arrow. What happens when I slide A down 6? 1, 2, 3, 4, 5, 6. Then my A double prime is here. And what do I get? I get a triangle that has been moved 6 units down, right? Can you see it here? This triangle right here? Did we get the right triangle? We did not. We got 2 of the 3 vertices that are correct. But when you do a translation, the orientation means the direction that it's pointing stays the same, right? If I were to ask you what direction does this triangle point, right? A's at the top, right? If I were to ask you this one, where's A? A is down at the bottom. On this one right here, A is at the top, right? So in a translation, the orientation has to stay the same. This one has a different orientation, so this one is going to be false. So we were looking for true, true, and false. All right, spent a long time on that one, but transformations are important. Plus, I think they're kind of fun. All right, question 20. I'm going to zoom back up to 100% here. Here we go. All right, parallel lines A and B are cut by a transversal line M and shown in the diagram. The measure of angle 2 is less than the measure of angle 4. All right, so before we read the instructions here, let's just look at the information that's given. First of all, they told us that these lines are parallel to each other. So parallel lines are lines that have the same slope. They will never intersect. So let me try that one more time. Sorry, looks like it's going to kick up a little bit. Forgive my sketch. A and B are parallel. They will never intersect. They go on forever and never, ever, ever, ever touch. They have the same slope. This line right here, M is called the transversal. A transversal is a line that intersects two other lines at two distinct points. And when you have two parallel lines cut by a transversal, you get these special angle pairs. They've numbered them 1, 2, 3, 4, 5, 6, 7, and 8. And you should have studied some of these relationships, right? Like angle 1 and angle 6. Those are called sorry, my bad. Oh, can we fix this? Undo that. There we go. I did not want to get rid of the line. I just wanted to get rid of the orange there. All right, here we go. Angle 3 and angle 6. Those two are called alternate interior angles. Angle 1 and angle 8. Those are called alternate exterior angles. Angle 3, angle 4, and angle 8, those are called corresponding angles. And then angle 3 and angle 5 here, those are called consecutive interior angles or same side interior angles. And what you find out is those special angle pairs either are going to have a sum of 180 or they're going to be congruent to each other. So they've asked us to look at angle 2 and angle 4, and they are saying that angle 2 is smaller than angle 4. So angle 2, we're going to use these inequality symbols. Angle 2 is less than angle 4. It's kind of confusing because the angle symbol looks like an inequality symbol. Angle 2, that symbol right there is less than. Angle 2 is less than angle 4. All right, so for each comparison, select the symbol that makes the relationship between the first quantity and the second quantity true. So they want us to look at 1 and 6. They want us to look at 1 and 6. Well, you can kind of just tell from the diagram, can't you? That, that 1, which is an obtuse angle, and 6 is an acute angle. Obtuse means greater than 180 degrees, and acute means less than 180 degrees. That 1 is going to be greater than 6. Now, you're not always going to be able to tell by the diagram, and sometimes diagrams can be deceiving. All right, but let's take a look right here. Angle 2, and angle 6. I'll write it up here. Angle 2 and angle 6 are what we call corresponding, not corresponding, we call them corresponding angles. And corresponding angles are congruent, or they have the same measure. So 2 is smaller than 4, correct? But 2 and 6 are equal. 1 and 4 are called vertical angles. 1 and angle 4 are called vertical angles. And vertical angles, guess what? They are also congruent. So here we go. Let's do our reasoning here. We know that 2 is smaller than 4. And we know that 4 is equal to 1. So 2 is smaller than 1. 2 is smaller than 1. But 2 is equal to 6. 2 is equal to 6. 2 is smaller than 1. 2 is equal to 6 or congruent to 6. Therefore, 6 must be smaller than 1. And if 6 is smaller than 1, then 1 is bigger or greater than 6. All right, so I think I made that way more complicated than it needed to be. I hope you understand what's going on. All right, so I'm going to clean all this up because I've made a big mess here. Let's look at 3 plus 5. All right, 3 plus 5. These two angles right here, these are called consecutive interior angles, or sometimes we call them same side interior angles because they're on the same side and they're on the inside of those parallel lines, and those have a sum of 180. So the measure of angle 3 plus the measure of angle 5 equals 180 degrees. All right, and over here we have 7 and we have 8. Well, 7 and 8 form what we call a linear pair. And guess what the measure of angle 7 plus the measure of angle 8 is? Since it makes a straight line, linear pairs together have a sum of 180 degrees. So 3 plus 5 is 180, 7 plus 8 is 180. So we're looking for an equals here, right? We had a greater than here. That's what we were looking for. Greater than, and we want equals. So we're going to select that, and we're going to select that, and we're going to happily move on to question number 21. All right, 2 to go in our video today. This is seeming to take a bit of time today. We got some problems that are taking a little more time to explain. All right, a scatter plot shows the relationship between the number of sweatshirts sold and the temperature outside. The y-intercept of the estimated line of best fit is 0b. Enter the approximate value of b in the first response box. Enter the approximate slope of the estimated line of best fit in the second box. All right, so a scatter plot. All these points are scattered. They are plotted, so we call this a scatter plot. This line right there, go back here, that line is what they are calling the estimated line of best fit. This is what someone said, I think this line best models this data. Some of the points are above it, some of the points are below it, but the slope, the trend, sometimes we call this the trend line. This is the line, the estimated line of best fit. And as hopefully you know, a line can be written in the form y equals mx plus b, slope-intercept form, where m is the slope and b is the y-intercept. And the y-intercept can be written as 0b for every y-intercept, x equals 0, and it's the place where the line crosses the y-axis. So here is my y-axis, and here is my line of best fit. So right there right there would be my y-intercept. And it sure appears to be about 250. About 250. All right. So for my y-intercept here, I'm going to be putting 250. And by the way, that's 250 sweatshirts sold when the temperature is 0 degrees. That's what that y-intercept means. Now they also want us to find the slope. All right, so many of you know slope as rise over run, or change in y over change in x. Maybe you hopefully know the formula y2 minus y1 is how you find the change in y over x2 minus x1. Sometimes we say the vertical change over the horizontal change. So on this line, I need to find 2 points that are on the line and use that to approximate the slope. All right, so I'm looking at this line and I'm looking for a point that's on the line and also on the grid. So we already said this point we're going to say is on the line, right? So if I travel down, it looks like maybe that point right there is on the line. So it looks like I went down 1 and over 3. Maybe that would be the slope. Well, you know how you check it. You do it again and see if you're back on the line. If I go down 1 and over 3, I'm approximately back down on the line again. And if I go down 1 and over 3, it's close. It's not perfect, but I would say that's a good estimate. So it is down 1 and right 3. That's our slope, and the letter we use for slope is m. Well, down 1 would be a -1, and right 3 would be 3, so our estimate of a slope would be -1/3. If Slope Dude were on this line, he would say that the slope is nice negative, right? Nice negative. Have you guys seen that video? If you have not seen the video of Slope Dude, I encourage you to go to YouTube, search Slope Dude because it is a great video. All right, 250 and -1/3. So I'm going to go right up here, put my cursor there, type in 250. All right, now if I want to do -1/3, I'm going to go down here and put the negative sign. I'm going to use the fraction template here. I'm going to put a 1 on the top and a 3. Whoops, what happened? Darn, I messed up here. So let's go back and see if we can fix that mistake. So try this again. I'm going to choose the fraction. On top, I'm going to put a 1, and on the bottom, I'm going to put a 3. There we go. -1/3 for the slope and 250 for the y-intercept. All right. All right, question 22, the last one for the video today. All right, so a cross-section of a ramp is shown. The length of the base is 45 inches. There it is. And the height of the ramp is 28 inches. Enter the length x of the ramp in inches. All right, so they gave us this distance right here. 45 is the base. That is what we call a horizontal. That's what we call a horizontal line. So actually here, let me drop the arrows. So this right here is a horizontal line. If you want to know the distance of a horizontal line, you can just subtract this value from this value. So they didn't put this on a coordinate plane, but if I call this 0, 0, then what would this have to be right here? This would have to be 45. And if I wanted to know this distance, I could simply go 45 minus 0, and I would get 45. All right, what about this vertical distance? Straight up and down is vertical. If this is 0, can you tell me what that would have to be? That's right, that would have to be 28. So if I wanted to know this distance, I could simply go 28 minus 0, and I would get 28. So to find a horizontal distance or a vertical distance, all right, if you want to know a horizontal distance or a vertical distance from A to B, you can simply do A minus B, and to make sure you don't get a negative distance, you can take the absolute value. So that's how you find a vertical or a horizontal distance. It's the absolute value of A minus B. Now, if it were on a grid, we can also count the squares. But how, ladies and gentlemen, do you find a diagonal distance? Can I do 45 minus 28 or 28 minus 45? And the answer is no. When you want to find a distance that is not vertical or not horizontal, then you need to use the Pythagorean theorem. You also can use something called the distance formula, which is simply the Pythagorean theorem used on a grid put into a formula. So, all right. So the Pythagorean theorem says if you have a right triangle, which we have, you have two legs. We're going to call one of those legs A. We're going to call the other leg B, and we're going to call the hypotenuse C. So the legs are the two sides of the right triangle that together make the right angle. And C is the hypotenuse. It connects the end of the vertical segment to the end of the horizontal segment in this case, or the end of one leg to the end of the other leg. And the Pythagorean theorem says if you know what A equals, square it. If you know what B equals, square it. Add A squared plus B squared, and you will get C squared. So A squared plus B squared equals C squared. All right, but we're not actually trying to find C. We're actually finding X, which is going to be the same as C, right? So that means we want not C squared, but C. So what do? We take the square root. All right, so here we go. So C, which in our case is actually going to be X, right, is going to be the square root of A squared plus B squared. Well, A for us is 28, and B is 45, but we have to do what with those? We have to square them, and we're going to square root them. Quick note before we do this, A and B are interchangeable. I could have called 28B and 45A. Either leg can be A, and whichever one you don't make A, you make B. So the square root of 28 squared plus 45 squared is going to be X. And thankfully, they have given us a calculator. So I'm going to go ahead and click on the calculator. And the calculator is going to come up. I believe the calculator is going to come up. There we go. All right, and we wanted to do, what was it, 28 squared, right? Plus, what was the other one, 45 squared? And we get that answer, 2,809. But then what do we want to do? We want to take the square root of 2,809. So I'm going to actually do it now. I'm going to go the square root of 2,809, and I get 53. All right, so now that I've done that, it probably would have been better to start with the square root, and inside the square root put 28 squared plus 45 squared. And we could have done it all in one fell swoop, and we get 53. So sometimes calculators do things in a different order. That's why it's good to practice with the calculator that they use on the test. This is the actual calculator that will be on the CAASPP test when you use it. So it's good to know how it works. So the answer that we want is 53, which makes sense because the hypotenuse has to be the longest side in a right triangle. So it's bigger than 45, but it's not crazy bigger. So if we gotten something like 530 or 5.3, we would have known that both of those were wrong because it wouldn't make sense. So 53 is the answer that we are looking for. That takes us to question 23, but we're going to save that for the video next time.